convert standard notation to scientific notation. So the scientific notation format, as we saw in the last video, right? It's a number times 10, right? That's our base number. And then we have an exponent, which would be to some kind of power, right? And we're just going to show it as a. Now remember, establishing the first number, we're going to move the decimal so that only one number is to the left, right, of the decimal. Right, and so this can look like this. So 4.2167, right? So we have only one number to the left, right, of the decimal. So that's like in the one spot, right? And so that's kind of that would be the format of our number. And then we're going to be determining the exponent, right? So what does that mean? Right, well, we're going to count the number of times that the decimal is moved. Now, for us to determine what the integer is, like our a, right? So if we have to move the decimal and then we move it to the right, if it's moving to the left, that means it's going to be a positive exponent, right? So positive a for this case. And then, but if the decimals move to the right, that means the exponent is going to be negative. So that's in regards to a small number, right? And then we have to move it to the left. That's a bigger number. So kind of helps our maybe intuition on what that looks like. So let's go ahead and look at some examples. So example 1. So radio stations have frequencies in the range of 88 to 108 megahertz. So a radio station has a frequency of 967 megahertz. And then this right here, megahertz, is in regards to a metric, right, prefix. And so really what that means is that we have this and just regular hertz, right? If we remove the mega, this is what it looks like. And we need to go ahead and change this number to scientific notation. So 1, 2, 3, 4, 5, 6. So there's 6 there. Now, let's go ahead and see, we have a decimal right there. And so for us to go ahead and move the decimal, we only need one number to the left of the decimal. Right now there's a lot of numbers, so let's go ahead and move it. So we can go 1, 2, 3, 4, 5, 6, 7, 8. So if we change it and put the decimal right there, it's going to look like this, 9.67. We don't need to add the zeros because it's understood that anything after, right, with the decimal and there's numbers and just zeros, we can just leave them, right? They're just trailing zeros that don't mean anything after a decimal. So let's go ahead and just leave it as 9.67. Now, we have just one number to the left of the decimal. That's perfect. And we go times 10. And now for us to figure out what a is equal to, notice when we go, right, if we go back, if we move to the left, we're going to have a positive exponent, right? And so that would help us kind of understand that if we have a positive number up here, that means it's going to be a large number, which is exactly what this is. It's a really large number. In fact, we moved it 8 times, so we're going to indicate that by going 10 to the 8th power. And it's positive, so we can just leave it as is, and that would be our solution. Now let's go ahead and look at the next example. So example 2, we're going to convert now this number to scientific notation. So let's go ahead and rewrite this. We have 0.000, then 2, 4, and then a couple more zeros. Now remember, we want to go ahead and move this decimal so there's only one number to the left of it. So we're going to actually put it right here because these are just zeros, and so we wanted to have a number between 1 and 9. So let's go ahead and move this decimal. So we're going to move it 1, 2, 3, 2.4. So let's go ahead and rewrite this. So if it's 2.4, and then we don't need to actually add those zeros, right? It doesn't do anything to add these zeros after. So we can just leave it as 2.4 and then times 10. Now notice we move the decimal to the right. So we have a really small number here, right? 0.00024 is a really small number. So we're going to indicate that by, right, as we move to the right, a negative exponent. So that's going to tell us that we have a small number and we moved it to the right. So how many times do we move it, right? So it's 1, 2, 3, 4. So it's just -4, and that would be our solution here. Now let's go ahead and look at the next example. So example 3. Let's convert this number to scientific notation. Now, we have a decimal here. We want to get it to right here, between the 4 and the 6, because we just need the one number, right, to the left of the decimal. And right now, there's 5. So let's go ahead and move it. So we have 1, 2, 3, 4. So we end it right there. Now we notice we moved it, right, to the left. Now we're just going to go 4.607. We don't need to include the 0 because it's understood that there would be a 0 after that. Now we can go times 10, and we moved it 4 times, and we moved it to the left, so it's going to be positive. So that would be our solution here. So let's go ahead and do the final example. Example 4, we're going to convert this number to scientific notation. We have 0.03781. So we have a decimal here, but we need to get it right between the 3 and the 7. So let's go ahead and do that. So if we go over 1, 2, we wouldn't have a decimal right there. So we just have the one number between 1 and 9 to the left of the decimal. So what would that be? 3.781 times 10, and we moved it over twice, so that'd be -2. Because, right, we moved it to the right. So it's a smaller number, so we indicate that all by the negative. And that would be our solution.